Welcome everyone today. My name is Mr. O and today I am going to be covering the SAT Practice Exam 1, Section 4, which is the math section, specifically numbers 9 through 11. Feel free to check out the other prior videos that we have covered based on these questions for math, but for today I am focusing on numbers 9 through 11. And as usual, what I do is that I first do the question real quick, and then I explain that question in depth so that you can understand how to do the problem. And so I shall get started. So for number 9. Okay. So for number 9, my final answer is A, and I do want to explain how I approach a lot of these word problems, but the important thing when I approach these word problems is that I must make sure to be efficient and to not waste too much time trying to dwell on the scenario itself, but to get to the answer. And so for number 9, the one thing I did was that I ignored this sentence completely because I realized right off that it wasn't going to really help me. My goal was to find the units for these pieces for variables. If you notice, I put notes right here so that in case I need to use it, it helps me reference it and get to the answer faster. But the question asked me basically what to solve, but I didn't even read this question because I looked at the answer choice and noticed that I need to isolate t by itself. And so because of that fact, I'm going to do number 9 and show you how I was able to get to A so fast. But the point is this. So for number 9, I'm going to copy down the question. Okay. So for number 9, the important thing that I noticed when you had to do number 9 was that that I needed to isolate t, as I mentioned before. And so in order to isolate t, I need to get rid of everything that's surrounding t before I could isolate it. And the first thing I need to do is get rid of any constants outside. So outside of this currently is 1052. And so I need to balance this equation going down. This cancels out. And so it'll be a minus 1052 equals to 1.08t. Afterwards, what I did was I divided by 1.08 because I'm not going to subtract something that's being multiplied. I need to do the exact opposite. Just as much as this number is being added to this equation, I need to do the exact opposite and move it to the other side. And so I need to divide. And what happens is that I'm going to have the final answer a minus 1052 divided by 1.08 equals to t. And so with my final answer being this case, I look at my answer choices and I notice, oh, okay, so a minus 1052 minus 1.08t, and so that's why my final answer is A for number 9. And that concludes my explanation for number 9. Just to continue on to the next questions, so for number 10, I'm going to go ahead and get started on number 10. So number 10 states this: at which of the following air temperatures, okay, so, and so for number 10, my final answer is B. And if you noticed right off, what I did was that using the TI-84, I was able to get to the answer for this specific question. So when I was doing this question, the important thing I noticed, at least for me personally, was that I needed to make sure that the 1,000 feet per second aligned with the variable that I was going to input that value into. And so I inputted 1000 into here, and then I went about solving it out. Very similarly to the prior question, I did the very similar systems, but I also want to note that because this is a calculator section, you must make sure to use the calculator whenever you can to be accurate on your answers. Not always do you need to use the calculator, but I believe that using the calculator on certain circumstances like this is the best timing to use them. And I personally recommend the TI-84, which is approved under the CollegeBoard. The important thing why is that that for me, at least TI-84 is very user-friendly. It's fast, it gets to the point, what I need, and it's not too much extra, functionalities. TI-89 also works for me, but there's some functionalities extra stuff that I feel like adds to the layers of unnecessary computational power that I don't need for specifically the SAT-1. And so for this question, and I'm just going to show you real quick how I was able to go about doing so, The thing is that as I mentioned before for number 10, what I did first was for number 10 was that I inputted the value into there. So originally 1052 plus 1.08t, and I plugged in 1002 here. So what happens afterwards is that now my question states this. Afterwards, what I did was I subtracted 1052. So it's very similar to number 9 as I mentioned before. And so it'll be 1.08t. And then divided by 1.08, divided by 1.08. And this is where the calculator functionality, the negative 52 divided by 1.08. But I do want to note one thing. When you're typing negative in front of the number, I don't use this negative number, this button right here, because this is subtracting. If you even notice, it even states answer minus. It doesn't even let me use the negative properly. So the point is that the negative I'm supposed to use is all the way on the bottom of this calculator right here. And so negative 52 divided by 1.008, and it gives me negative 48.14. So t equals to negative 48.14. And when I look at number 10, the only option that looks near to negative 48.14 is the answer B, which is my final answer for number 10. Okay, to continue on to number 11. So for number 11, okay, we're going to get started. So which of the following numbers is not a solution to the inequality 3x minus 5? Okay, so okay. Okay. So for number 11, the answer is A. And now I'm going to go into the explanation as to how I was able to get number 11. So for number 11, I'm going to go ahead and copy down the question real quick. So for number 11, it states which of the following is not a solution to this. So I'm going to do 3x minus 5 greater than or equal to 4x minus 3. Okay. And so for this question, the important thing you must understand for this question is that I need to move all my variables to one side and move all of my constants to the other side. And so for this question, the thing I noticed at least is that I need to move one of the variables over. That's the thing I need to do. For me at least, the thing is that I usually leave the bigger variable value alone. So if you notice, 4 is bigger than 3. So I'm going to leave 4x alone. The reason why is that if I move the 4x over here, it's going to end up creating a negative x value, which I have to actually deal with later, and it requires me an extra step. And so personally for me, that's a little bit extra work, and I don't want to deal with that. And so what I'm going to do is move 3x over first. What happens is that I'm going to have x minus 3, bring down the negative 3 here, and I'm going to bring down the negative 5 here. So after I do this, my goal, as I mentioned, is that move all constants one side, move all variables the other side. And so for this case, I need to move the constants now. So I'm going to move plus 3 over so that I have negative 2 is greater than or equal to x. As I mentioned before, it's greater than or equal to x. And so what does that mean? That means that all the values I plug into x right here has to be either negative 2 or greater. So for example, this could be negative 2, could be negative 3, could be negative 4, negative 5, negative 6. Be aware, as I mentioned, it has that these values have to be smaller than negative 2. And so if you think about the negatives, what happens is that actually the quote-unquote, this value becomes quote-unquote like the normal positive value becomes bigger. With the negative, it actually gets smaller. And so when I look at number 11 and I'm trying to understand this, well, if you notice, I put negative 2, I put down negative 3 works, I put negative 5 works, but there's no negative 1. And so that's why for number 11, the answer is A. And that concludes my explanation for today. Thank you so much for watching. Please do like our Facebook page and subscribe to our YouTube channel. We will continue to make more videos like this in the future. Have a good day.